Welcome to this week's episode of Weather Extra. I'm First Alert Meteorologist Jillian Johnson. Our weather here at home started to feel much more like what a typical summer feels like as temperatures began to rise during the past week. But our warming weather was nowhere near the major heat wave that hit the eastern and central parts of the nation last week. Take a look at the heat risk map from the National Weather Service from this past Thursday, July 24th. The orange and red colors represented those Americans that were under moderate to major risk of being affected by hot temperatures. 144 million Americans were under moderate risk, nearly 60 million under major. Heat alerts like heat advisories to extreme heat warnings were also issued nearly every single day last week. Now, what caused the heat was a ridge of high pressure, or the heat dome, which not only brought very hot temperatures, but also brought in very muggy air as the peak of summer settled in. Nearly 200 million Americans in cities stretching from the south through the Midwest and even across the Atlantic coast recorded their highest temperatures of the year so far. While many didn't see new record highs from this heat wave, they did see temperatures reach into the upper 90s, which is well above the normal despite it being the middle of summer. What made it all worse was the high dew point temperatures, which made feels like temperatures exceed 100 degrees in many major U.S. cities, with some spots feeling closer to 110 to 115 degrees. And many of those northern states don't have air conditioning to help cool them off, which means no escaping the heat. So far this summer, more than 24 U.S. cities are experiencing one of their top 5 warmest summers on record. Now again, here at home, in Central Texas, we just started to feel the heat rise last week. The month of July has mostly been all about rainfall and cooler than normal conditions. For more on this, we bring in First Alert Meteorologist Sean Bellafiore.
July 2025 has been a very weird month of weather across Central Texas, and unfortunately that has been spurred by all of the devastating heavy rain that we saw to kick off the month. Since the beginning of the month, we have struggled to reach our average high temperature, only climbing above average for the first 2 days of the year. And as of the date of this recording on July 24th, we are on a 3-week-long streak of cooler than average high temperatures, and we're also on pace for the 14th coolest July in history if you take a look at the average high temperatures. It's rarefied air that we are in. We have seen a 21-day streak of below average high temperatures confined entirely in the month of July, only twice since the year 2000, and one of those years was in 2021. We did notch a long streak from the 1st all the way to the 24th, with a couple of days that were right at average at the end of the month. But if you go back to July 2007, the entire month of July featured cooler than average highs. And by the by, this was actually a part of the longest cooler than average high temperature streak, a total of 52 days from June 20th all the way up until August 10th. If we're taking a look at 3-week-long streaks of cooler than average highs, the longest of which was in 2007, the shortest in 2004, 21 days ending on February 16th. And a big shout out to the National Weather Service in Fort Worth for compiling some of this data for us. Now, as we move our way deeper into the month and deeper into the summertime season, we're still looking out for our first triple-digit day of the year. If we take a look back in 2021 and 2007, maybe for some hints as to when that may happen, well, in 2021, September 5th was the first 100-degree day, and in 2007, it was on August 12th. Reporting in the studio, Sean Bellafiore, KWTX News 10.
Thanks, Sean. But not long ago in July, Central Texas was experiencing some of the hottest temperatures ever recorded in history. For a look back at some of those records, here's First Alert Chief Meteorologist Brady Taylor.
We had a week worth of records back in 2018 this time of year. Between the 18th and 23rd, we saw records that are still holding on now. Between the 18th and 22nd, high temperatures 108 or 109. But the day that gets all the attention was the 23rd, when we saw our all-time hottest temperature ever of 114 degrees. Now, you say, why the difference compared to what we saw then to what we see now? Kind of 2 factors. First of all is how muggy the air is now compared to then. Back in 2018, we saw a high of 114. Humidity rates were extremely low. Our afternoon humidity rate only at 15%. This year, afternoon humidity rate on the 23rd, 45%. And this is how that heat index value comes in as a key factor. That 114 with the dry air actually felt like 113. This year, 95 with the high humidity rates, push the heat index value up to 106. The jet stream pattern much different as well. We've got high pressure still controlling our weather, but the core of that high has been just off to our east. Back in 2018, huge, very strong dome of high pressure right over the state of Texas and much of the desert southwest. On the 23rd, that ridge shifted off to the west just enough, actually allowed a front to move in. That dried the air out more, and that front actually compressed the air some across central Texas. That caused the temperatures to spike. Now behind the front, we did cool the temperatures off some. The high the day after, 101.
While most of July has been cooler than normal, we are about to head into the hottest month of the year here in Central Texas. On August 1st, our average high is 98 degrees and the low is 75. Now, thankfully, in the month of August, we start to see our average temperature slowly cool off as we inch closer and closer to fall in September. By the end of the month, the average high falls to 95 and 71 for the low. Although the hottest temperature ever in Central Texas history was recorded in the month of July, we've seen some dangerously hot weather in August too. The hottest August day was back in 1969 on the 11th when temperatures reached 112 degrees at the Waco Regional Airport. And here's a pretty crazy stat. Every single day in the month of August, daily record highs are at least 105 degrees, but many of them are hotter than that. There's been some very rare cool air that's moved into Central Texas in August. The record coolest day in the month was back on the 25th in the year 1992 when temperatures dropped down to 53 degrees. Now, August is mostly known for the very hot weather. We typically see the most 100-degree days in the year happen throughout the month of August, with 11.4 of them occurring on average. But our average last 100-degree day also falls in this month on the 30th. Let's switch gears and talk about rainfall throughout the month of August. August is typically the second driest month of the year in Central Texas, with a little over 2 inches of rain falling on average. Now, the wettest day in the month's history fell back on the 18th, when 4.76 inches fell in the year of 2021. And the wettest August in history was back in 2008, when over 10 inches of rain accumulated in the 31 days of the month. And there's only been one August in our history where no rain fell, and that happened over a century ago, back in 1902. So we just saw what August should normally be like for us in Central Texas, but what is the forecast calling for? Well, for more on that, here's First Alert meteorologist C.D. Finley.
Well, we're now rounding out the month of July, and as we look ahead to August with the latest monthly outlook from the Climate Prediction Center, in terms of temperatures, we have equal chances of above or below normal temperatures heading into the month of August for Central Texas. Meanwhile, the Pacific Northwest is actually likely going to be dealing with those above normal temperatures. But here in August, our average is usually right around 97 degrees, and we have about 50-50 chance of hitting above or below that mark. So kind of a 50-50 chance there. Same goes for the precipitation outlook. In fact, Central Texas got equal chances of above or below normal rainfall here heading into the month of August. Meanwhile, as you take a look off to the East Coast, it's got some higher chances as we kind of ramp up the Atlantic tropical season. But for right now, we're mainly just talking about a 50-50 chance in both temperatures and precipitation heading into the month of August.
Coming up after the break, we learn how a cool block in one Massachusetts city could provide a template for combating extreme heat. More on this when we come back. Welcome back to Weather Extra. Extreme heat is now the deadliest weather event in the United States, killing more people than hurricanes, wildfires, and floods combined. Cities are especially vulnerable to excessive temperatures because of what's known as the urban heat island effect. Here's more on how cool blocks could help during extreme heat.
There are always some days that I feel like we live in the middle of the Sahara Desert.
For Arwa Aitchib and her mom Wafa, summertime in Chelsea, Massachusetts means trying to beat the heat.
What is it like in the height of summer on a really hot day around here?
I just can't stand it. It's like I feel sticky, it's humid out, and if you go out, the sun immediately burns your skin.
Their neighborhood outside Boston offers little shade.
We had no tree over here at all.
Chelsea is an urban heat island, covered in pavement and vehicles that soak up and radiate heat. Climate Central research shows peak temperatures in these areas can be 15 to 20 degrees hotter than greener ones.
We're basically an island of hot stuff.
Bianca Bowman works with Green Roots, a local group trying out cooling solutions on this one single block in Chelsea they call the Cool Block.
So we looked at those spots and said, okay, where can we throw as many solutions as possible to cool those areas down?
1, 2, 3.
They've planted more than 100 trees, resurfaced streets in lighter colors to reflect heat, and nearby rooftops are being painted white.
So when you paint a rooftop white, it's actually reflecting heat instead of absorbing heat.
Fixes like these could help save lives as climate change makes heat waves worse. Climate Central found that 88% of U.S. cities now have more extremely hot summer days than they did 55 years ago.
See that sensor in the tree right there?
In Chelsea, Boston University researchers are using sensors to track temperature changes on the cool block.
Research shows that parks, trees, and green spaces can reduce peak urban temperatures by up to 9 degrees. Of course, finding space in big crowded cities is not always easy. So the folks that design them have to make the most of what they've got.
Nothing but gravel was here.
Chris Reed designed Boston's groundbreaking urban forestry plan.
How many trees did you plant on this little strip of land?
400 trees, 1 acre. So you don't need acres and acres and acres of land. These kinds of places are in cities everywhere and can be transformed one by one.
Back in Chelsea, a park is replacing pavement behind the Eitscheib's home.
Does it feel like your neighborhood is getting better?
For sure.
I can agree on that one.
For Climate Central, I'm Ben Tracy in Chelsea, Massachusetts.
And here's something you probably didn't know. Scientists say the Earth is spinning faster this summer, and that's making some days marginally shorter. Thursday, July 10th, was the shortest day of the year so far. Scientific data shows that day lasted less than 24 hours by 1.36 milliseconds. Scientists say this past Tuesday, July 22nd, and Tuesday, August 5th, will also be shorter by more than 1 millisecond. The reasons for this are several, including the moon's gravitational pull and influence of the Earth's liquid core. The discrepancy isn't enough to be noticeable to humans and doesn't have any obvious effect on everyday life. However, the discrepancies can, in the long run, affect computers, satellites, and telecommunication. All right, straight ahead on Weather Extra, we learn more about the research being done that's working to reduce methane emissions from cattle. That's coming up in this week's Degrees of Science right after the break. Welcome back to Weather Extra. Methane is a very potent greenhouse gas that often gets mentioned when it comes to climate change. And one of the more significant sources of methane are cattle. So in this week's Degrees of Science, we're talking with a professor of animal science from the University of Nebraska, who's working on an international project that's trying to reduce methane emission from cattle through genetics, all while helping cattle producers as well.
Dr. Spengler, I guess off the top, why is it important to reduce methane emissions?
I would say two reasons. One, the global consumer has voiced their concerns over enteric methane emissions from ruminant animals. And of course, we're focused on beef cattle here in this project. The thing that I think gets overlooked is the economic impact that could have to beef cattle producers. Enteric methane is really an energetic loss. So when animals emit methane, that is energy, if you will, that could have been used to put on weight. And so a focus on methane emission is really another way to look at the efficiency of feed utilization. And that's where I think that beef cattle producers would be keenly interested in this.
So this initiative, it's interesting. So you are looking at more kind of the genetic side, or how these different cattle may produce methane, right?
That's exactly right. There's certainly evidence that methane emissions from beef cattle, or ruminants more generally, which should include dairy cattle and sheep, is moderately heritable. So to put that into context, average daily gain in beef cattle would also be something that's moderately heritable. So we've shown that we can implement genetic selection to change those things. So there's evidence that we can actually change the amount of methane that animals emit on a daily basis through genetic selection. And so that's one of the reasons why there's an emphasis on genetics here. The other thing is we know that genetic change is cumulative and permanent. In other words, if we continually put selection pressure on reducing methane, we'll make incremental improvements over time.
So are you looking, is it going to be like, you think, certain breeds may produce more, or is it just a genetic line or bloodline that could be producing more methane?
I think the answer is yes to both. So one of the things that we'll be able to do too is estimate the differences between breeds for the amount of methane that they may produce on a daily basis, but then also within a breed have an understanding for how much among sire or between animal variation there is. If I think about beef cattle producers implementing breeding programs now, they need to contemplate both of those things. Which breeds do I use, and then which animals within a breed I use? This trait will be no different.
So you're mentioning the industry side. You know, a lot of times when you start talking reducing methane emissions, you're worried about the cost on the producer or maybe reducing herd. Is this something that y'all could implement that really wouldn't cause any problems to the industry?
Yeah, and that's chief of mind. If I go back to the goal of trying to estimate the relationship between methane and all the traits that we know are economically impactful now, that helps us answer that question of if there is a desire to decrease methane, how much might I change the traits that either have a cost or a revenue associated with them for me now? Which gives us a sense then of, is it a financial gain or is there potentially a financial loss? If the latter, then what is the amount of money, if you will, that might need to be returned to the producer for decreasing methane in their herd? I think those are open questions, and a project like this is going to help shed some light on those answers.
So looking kind of broad scale on this, how much of an impact do you think or hope that this initiative will have when it comes to reducing the amount of methane production from cattle?
Yeah, so obviously we hope it's impactful not only in terms of reducing global methane emissions from cattle, but it really the impact it has really depends on the economic signal given to producers, which then determines how much emphasis they put on selecting for that in their breeding programs. So if there is clearly no economic incentive, either directly for methane or indirectly because of the benefits associated with feed efficiency, then I think it's reasonable to expect that there won't be a lot of direct genetic change. However, if there are economic benefits, either directly again for reducing methane or indirectly through improved feed efficiency, then I think we'll see a reduction steadily over time. But I'd emphasize as a beef cattle geneticist and also somebody that grew up on a beef cattle operation, there are a lot of traits that impact the economic viability of an enterprise. And never would I advocate that somebody go out and select solely for one thing. So this is going to be yet another tool in the toolbox for people to select for multiple traits simultaneously that impact the sustainability of their operation long term.
To hear more about this interesting research project, scan the QR code on your screen to watch on YouTube or go to KWTX.com/Degrees of Science. We'll be right back. Welcome back to Weather Extra. We just heard how cattle are significant methane producers on our planet, but 8 legs and thousands of feet below lies one very unique discovery. Dan Smith has the story behind how some sea spiders use methane to thrive and survive in this week's Moment of Science.
You never know what you might find on a deep sea dive. Crushing pressures can yield big discoveries, or in some cases, very small.
Collecting the spiders was kind of a happy accident.
Bianca Dalbo is a recent graduate from LA's Occidental College, and as a biologist, she'd been keeping tabs on expeditions to the Del Mar methane seep, a few miles off the coast of San Diego. A 2021 expedition collected animals in that rarely explored region, with a few sea spiders hitching a ride up the vacuum tube.
The point was just, let's look at a bunch of these animals and see if anyone has anything interesting going on microbially. So I spent some time going through a bunch of different animals, and it ended up being that the spiders had a really interesting story.
In 2023, it was Bianca's turn, along with Ruby Seal and Dr. Shauna Gofredi, to head out to sea, or seep, as it were. They ended up discovering 3 new species of sea spider living thousands of feet below the surface.
Each day is a long day of a dive happening, them sending samples up, and then everyone's in a frenzy trying to process everything.
Alvin up there is a legend in its own right, with more than 5,200 dives under its pressurized belt, including the first crewed dive to the wreck of the Titanic. Its little arms and other attachments helped collect samples in a place where humans couldn't exactly thrive. You may think of methane as more of a greenhouse gas, yet as the name suggests, it also seeps up from the seafloor in certain spots.
That's usually a result of things like tectonic activity. So these are things that are trapped subsurface, and then they find ways to make their way out. Same with hydrothermal vents and underwater volcanoes.
The team kept some of the spiders in a methane solution with tracker isotopes, helping them understand just how these spiders use it to their advantage, as your usual sunlight won't cut it at these depths.
The only other form of primary production that exists is chemosynthesis, and it allows for this whole world to blossom using compounds like methane as the energy source rather than sunlight.
It turns out that little microbes form a biofilm on these particular spiders, converting that methane to more usable food, which the spider then picks off itself for a snack on the go.
They've found a convenient creature to hitch a ride on. And then the spider says, "Don't mind if I do." And it's not that bad for the microbes because some of them will survive and continue to proliferate.
The sea spider's egg sacs are also exposed to these bacteria, so it may be a symbiotic relationship passed down through the generations, short as they are, and it may benefit us humans as well.
If none of these animals and none of these microbes existed down there, this would potentially be greenhouse gas that's released higher into the water column and maybe out into the atmosphere.
In a previous episode, we mentioned how only an estimated 0.001% of the deep sea floor has been explored, and Dalbo is eager to get that number up.
Chemosynthetic environments are super fascinating and have a lot of secrets left to be figured out.
For this week's Moment of Science, I'm Dan Smith.
Thanks for tuning in to Weather Extra this weekend. That's all we have for you on this week's show. We'll see you again next weekend.